to the second physics lesson on scalars, vectors, and the equation v equals x over t. Here we're going to know the variable and unit for velocity, time, and displacement. We're going to look at the difference between scalars and vectors. We're going to calculate the difference between the two when we look at distance and displacement. We're going to calculate speed and velocity of an object. We're going to look at instantaneous velocity and how it compares to average velocity, and just a little bit on acceleration in this lesson. We have our equations, the variables we're going to use, the units, unit abbreviations, so make sure that you are familiar with this. Right now, what you should be doing is when you think of x, you should start thinking m for meters. When you think of t, you should be thinking s for seconds. When you think of v, you should be thinking meters per second. When you think of a, you should be thinking meters per second squared. We'll talk more about this later on, but this is not a bad note card to make as you're learning your different variables and units. The main equation we're going to look at is v equals x over t. It's just a simplified version of this. I'll show you in this lesson what that exactly means and how it's slightly different. But v equals x over t is our equation for this section. Starting off, the first part is just what is different between a scalar and vector, and it's all in this picture. If you take a look at scalar versus vector, you should notice something's different. So this vector is going to have this direction side, where a scalar is not really telling you one way or another. A scalar in physics includes only a magnitude, so you need to know what the term magnitude is, and it is a number and a unit. If I'm talking about 5 meters, that's going to be different than 5 inches. So they both have numbers, but the unit kind of gives it a reference. Common scalars you're going to see are speed. The pool is 5 meters long. It has no direction. So the key here is no direction. That might be one of the more decisive things right here is what it doesn't have. No direction. 5 meters long, no direction to it. Speed, the golf cart can drive 10 meters per second, but I'm not actually driving it right now, and I'm not going one direction or another. Time's never going to be a vector. It takes 2 seconds. You can't put a direction on that. A vector in physics includes a magnitude, so the same thing as before, but now we're going to have a direction on top of it. So vector has a direction plus that magnitude. It's still going to have a number, it's still going to have a unit. For example, here, displacement, that's going to be a new term that you've probably heard of first here. Maybe not, hopefully not. But 5 meters is going to be the magnitude, and east is going to be the direction. If I am driving the golf cart, but now I'm going east, meters per second east, well, that's a vector because you have the unit, 10 meters per second, and you have the direction east. Acceleration, 4 meters per second every second. So now thinking about acceleration, we're not just going a direction, we're changing our velocity in a direction. So you're going to notice that it has a second. It's going to be meters per second every second. So let's look at distance and displacement. This picture should show you enough. If the street is 100 meters, it doesn't tell you you're going a direction or another. That's going to be the distance. The distance of the street is 100 meters. I'm not walking along it, it's just 100 meters. Whereas displacement is going to have a little bit more information. So think about distance is probably the term you use normally, whereas displacement is something that sounds familiar, but maybe you might not use it. You're not getting displaced all the time. But displacement, you're going to be going in a direction. So if this person in this picture is displacing themselves by 100 meters in an eastward direction. I walked along my street 100 meters east. You've got that direction here. It's just distance because it doesn't have a direction to it. You can walk 6 meters east followed by 4 meters west. So now we're trying to calculate the scalar distance. You're going 6 meters east and then you're going 4 meters west. Well, for the sake of the scalar, since distance is a scalar, you're just going to ignore this. You're just asking yourself, how much did you walk? So if you went 6 meters and you went 4 meters, you went 10 meters. All you do for direction for the scalar distance is you just add everything up. If there was 3 or 4 more things you did after that, you just keep on adding those numbers up. You disregard that direction itself. Now, when we're going with vectors, we need to take into account the direction. So this east and west is going to be very important. And so we're looking at how to calculate displacement now. So in order to do this, a calculator is not going to take an east and a west as a value. So you're going to have to do something different. You're going to have to turn these directions into signs, pluses and negatives. And the common ones we're going to go with the mathematical coordinate system. And this tells you a little bit more about it. and since this is a straight line 1D motion, we're never going to go left and then up or down or something. We're going to stay on that same single line. We're either going to go right or left over and over, or either we're going to go up and down, but we're not going to do both of these together because this is going to get into 2D motion, which is the next unit. So we're going to say right is positive, left is negative if we're going left and right. So let's go ahead and take let's go ahead and take this information right here. You get 6 meters east. Well, we're going to go ahead and we're going to turn this into a placeholder, and we were going to go with this placeholder right here. We're going to call this a positive 6 because we went east, so that's for the east. And then we went 4 meters west, and we're going to go ahead and take that, and we're going to make that a negative 4. That's going to be the placeholder for west. So the sign in front of the number is a placeholder for direction. There we go, there we go. And now all we're going to do this thing called adding vectors, and don't confuse it. Sometimes we're actually subtracting because this is nothing more than 6 minus 4. But we just go ahead and we add the vectors. It just happens to be this is negative 4. Now if you're writing on your paper, you might write down 6 minus 4 equals. And I want to keep these direction signs in there because we haven't taken into account the direction first. So we add the vectors, plus 6 plus a minus 4, and we get a plus 2. But we need to go ahead at this point in time, we need to undo this direction sign, and we got to turn it back into a direction. And when we started off calling east positive. So since we have a positive here, we're going to stick to that. We're going to go ahead and say east again. So we're going to get rid of the sign in front of the number. So I leave the sign in front of the number until I turn it back into a direction. I don't write down 2, I write down plus 2. And then at that point in time, it goes back into the direction, and you get your final answer, 2 meters east. So here's some practice. A dog walks 50 meters east and then 20 meters west. What is the distance? So what you want to think to yourself, direction does not matter. So you're going to go ahead and you're going to just add them up. So on your paper, if you have the paper, if not, just work with me. 50 plus 23 equals 73. So this person traveled a distance of 73 meters. Direction is not included. We don't care about that for, ignore that. This should say just distance. For the distance answer, it's going to be 73 meters. Now the second part of this, where the direction does matter, and if you're at home, try to do this on your own and pause the video, get ahead of me, walk through these different problems, and then come back and look at the answers. So if you're done pausing it, if you did pause it, here it is. The east is going to turn into a positive sign, so it's going to be plus 50. The west is going to turn into a negative sign, once again going with the whole coordinate system plus minus. So we're going to add these two numbers together and we get a positive 27, and we're going to go ahead and turn it back into a direction, and the direction is going to be 27 meters. We said positive was east, so we're going to go with east as the answer. Next one, and I already showed you the answer. We're looking for the distance when a bird has flown 850 kilometers south and then traveled 320 kilometers north. Unless I ask you to convert, I know in the last lesson, if you followed me, we were always converting to meters. If you're not asked to convert, you can keep it in kilometers if the units are matching. If one of these happened to be meters, you would have to convert to kilometers, or actually one of these was kilometers and meters, and they didn't tell you what to convert to. I would convert to meters, since meters is the MKS unit. But here it doesn't tell you to do anything except for just put them together, and you're going to be left off with the unit kilometers when you do this problem, because that's what you were given in the work. So since it asks for distance, you just add the numbers up. That's all you do, and you throw back on the kilometers. Now, what you may have seen in the last lesson, occasionally I put the unit in the numbers when I was adding, just to kind of show you that this number, this n thing, this unit comes from something else. Because these were kilometers, these were kilometers. I just leave it off often in the math, just not to confuse myself. Think my S's are for seconds or fives. Then lastly, you want to go ahead, they're asking you for the bird's displacement, so you're going to have to turn this north and south into signs, and south was, we're going to go once again with the coordinate system. We said down was going to be negative, up was going to be positive. Every time we use up and down, so south was going to be negative, so negative 850 plus a positive 320, and then you have your placeholder negative that results from adding these two numbers together. Negative 530, but we turn that back into a direction, and that becomes 530 kilometers south. Okay, now just taking a step further, we're going to look at speed and velocity. Now, speed is a scalar. This is going to be very important because you can only use distance, because distance is also a scalar, to find the speed. And in the vector velocity, you're going to use displacement to get to the vector velocity. And we're actually going to use the same equation right here. V equals change in x over t. And just let's take a second and look at what change in x means. X itself can mean displacement or a change in position. And so your change in position, another way to express delta F or delta X or change in X is the same as the final velocity. That's the little subscript. You're going to see this in physics. The little things underneath the main variable XF just describes F. So this is a final displacement minus the initial displacement. So the change in position, that's what this means, is your final position minus your initial position. And change in position itself is also called displacement. So you'll often see position or displacement meaning kind of the same thing. It's going to be a vector when it's talking about a changing of a position or a displacement, because you're going to be going a direction or another. So let's take a look at this. If you go from this, let's call this the 2-mile marker, and you go to the 7-mile marker, well, how far did you walk? You're walking to the 7-mile marker from here, so you're going to the right, but how far did you go? You went 5, and then what you did is you took the 7, you took the final displacement, the XF right here, and you subtracted the 7 from the 2, or the initial displacement, and you get 5 miles. And in this case, since I didn't tell you a direction, I could have said to the right, forward. If you're in my class taking a quiz and I don't tell you what direction you're going, forward works. If you just assume it right and you draw me a quick picture, I'll go with that too. I'll accept that. Okay, so going from a position of 10 to 4 meters, let's go ahead and pause the video. You probably saw what I just showed you. Try it on your own and tell me what it's going to be. Okay, so what we end up getting when we do this is we go from 10 to 4. The final was 4, not 10. So it's not always the biggest number that's at the end. The final was 4, and we subtract that 10 from it, which was the initial, because if you take a look at this animation, he's starting at 10. And we get an answer of -6 meters. But once again, the -6, we don't like negatives. We want to turn that back into a direction. And so in the case of this picture right here, we turn that back into the direction left. So our final answer, if it said displacement, it would be 6 meters left. If it said what was the distance that Tom traveled, it would just be 6 meters. Once again, scalar versus vectors. Displacement is a vector, so direction matters. So we're going to use this equation, same equation, the whole time for whether we're dealing with speed, but just make sure that if you're dealing with speed, you need to make sure you're using distance. Distance goes into speed. If you're trying to solve for velocity, it's going to be the displacement calculation that's going to go into velocity. So let's go ahead and answer this question. You walk 6 meters east followed by 4 meters west in 4 seconds. What is your speed? So direction does not matter. Let's determine the distance. When we determine the distance, we just add the numbers up. So we get 10 meters. And then we're going to make a givens list and solve for speed. So we have the 10 meters we determined up here by solving for distance. We know the 4 seconds right here. We throw that in. We want to make sure that, and right now it's insignificant, but in the future it's going to be more significant when we have more equations going on. But we are asked the question speed. Make sure that you have the variable v equals question mark. This is going to be important in determining your equation you're going to use. And when you're looking on the equation sheet, you're going to find something that has that x, the v, and the t in it. We find this equation, and now we're ready to go ahead and plug in the numbers. So our x was 10 meters. Our time was 4 seconds. We do the math, we get 2.5 meters per second. Once again, this right here, we were trying to solve for speed, so we're using the scalar distance to solve for speed. If we're solving for velocity, which we're going to do next, we're going to use the vector displacement. Okay, so let's do that. Now for velocity, we have to find the vector displacement, so we're going to have to include the easts and the wests in our calculations. So east was +6, the west was -4. We add those two numbers together, we get +2. We want to turn it back into a direction, so that +2 meters becomes 2 meters east. And now we make the givens list. We complete this givens list. We add the 4 seconds, so we know and then we look for the question itself is what is your velocity. So we want to make sure we have that question, and that gets us to the equation. From there, we're going to go ahead and we're going to plug in our variables. And I just left the east. Often if I was doing this problem, I'd leave everything off until the very end, but I'm just showing you that meters and east is in this variable, and that's what turns into this right here. The 0.5, the meters per second, comes from the meters in seconds. The east comes from this east. It was all really in the equation. It was never lost. So if I was ever using, if you saw me doing this on paper, it'd probably be v equals 2/4, but then in my final answer, I would have went ahead and turned it into this. I probably wouldn't have drawn everything out. But it might help you out just to not make mistakes. Okay, what's the velocity of a plane that travels 500 meters north, followed by 5,000 miles, not meters. So be careful, since we're using miles. We want to make sure that these things connect the dots. It doesn't have to be meters if it doesn't tell you to convert to meters. If we have miles and miles, we can go ahead and we can work with those numbers. If it happened to be miles and meters, then I would always convert to meters first. But let's go ahead and answer this question. We're going to go ahead and figure out the displacement, because it's asking you for velocity. So we're going to have to take into account the north. We're going to have to take into account the north, and they happen to both be north. So we have plus 5,000, and we're going to add that to a plus 10,000. Our answer becomes a positive 15,000, but once again, that's not good enough. Let's turn this back into a direction, and that happens to be north. So we have 15,000 miles north. Mi is the symbol for miles, and it takes 20 hours. And I'm not mixing hours with anything else like seconds, so I'm going to keep this unit as hours. And we're going to go to, we're solving for v equals question mark. So on your paper, you should have all these givens. And we then write in the equation, and then we plug in everything. So we plug in the 15,000 miles north, we plug in the 20 hours. And when we do the calculation, 15,000 divided by 20 in a calculator is going to be 750. And in this case, the unit is going to be miles per hour because it's derived from miles and hours that we went into this. And we're not going to forget north because this is a velocity. This is a vector, so it needs a direction. What's the speed of a plane? Okay, so here now we have the speed of a plane, and what you're going to notice is we're going to add these numbers together because that's what we'd always do. We disregard for speed of a plane, and we disregard the direction. It doesn't matter. We go 5,000, then we go 10,000, we add those together. It just happens to be that we're going the same direction, so the magnitude, remember the term magnitude? The 15,000 right here, and the 15,000 right here, this is the magnitude of it. The magnitude is the same because we didn't change directions. Only when we change directions, the magnitude will be different. So we make a givens list. We got our 15,000 miles, we got our 20 hours, and we have our unknown, or velocity we're trying to solve for, and we just plug and chug. So the velocity equals 15,000 miles over 20 hours, and we get an answer of 750 miles per hour. But in this case, we don't want a direction because we were asked for speed, and speed is a scalar, which does not include a direction. Now, just take a look at this picture. Look at what's going on in this animation. Notice how this guy's going faster, stopped, and then went faster, and then went slower, then went a little faster. The difference between average velocity and instantaneous velocity, instantaneous is what he's doing at this moment. So notice how at the beginning he stopped. Well, his instantaneous velocity at that moment was 0. And notice how he's going, when he goes slower, his instantaneous velocity was, his first velocity was 6 meters per second, his second one was 4 meters per second. Well, that's the velocity at that moment, whereas average velocity is going to be different. Average velocity, you take the entire distance traveled, you take the entire time traveled, and you're going to put the average, the entire displacement that he went, and we're going to put it over the entire time. And so notice how that average velocity doesn't change. No matter how much he stops or goes, it's the entire trip. Okay, and occasionally you're going to have multiple distances and times. So here we have Sally walking 5 meters east in 2 seconds. She stops for 10 seconds. Then walks an additional 10 meters east for 3 seconds. What's her average velocity? If you ever have this, you're just going to go ahead and find the total displacement. So we had 5 meters east, stopped, which is 0 meters per second. So watch out for words that mean numbers. And walks an additional 10 meters. So we have the plus 5, the plus 0, the plus 10. We add all those numbers together. We get 15 meters positive, which becomes 15 meters east. Now we want to find the total time, so we're going to take into account the times. We have 2 seconds, 10 seconds, we have 3 seconds. We're going to add all those numbers together, and we get 15 seconds. Finally, we make a givens list from that information, and we solve. Plug the numbers in, and we get an answer. The velocity is 1 meters per second east. Something I didn't mention before, anytime you're doing work on a piece of paper, I need to see your final answer. I want to see it first. Circle your final answers if you get a chance to do that. Okay, let's look at this one. June moves 5 meters south in 3 seconds, then continues south 3 meters for 3 seconds, and finally turns and walks 10 meters north in 5 seconds. What's her average velocity? Go ahead and pause this if this is a video, not live, and answer this question, and then come back and check it with my work. Okay, so we have 5 meters south, so it's a -5, and then we have 3 meters south, so this is a -3, and then when we turn and walk 10 meters north, so this is going to be a +10, we add those together and we get a displacement of 2 meters positive, which becomes 2 meters north. We find the total time by just adding the times together. She moved the first segment with 3 seconds, the second segment with 3 seconds, the last segment was 5 seconds. Put those together, we get 11 seconds, and then we go and make our givens list, and then we solve for it. So you get 0.18, and anytime you have a point, put a 0 in front of it. It's easier to see the decimal place. 0.18 meters per second north. How much time does it take to go 500 meters at a speed of 20 meters per second? Okay, so we're not always going to be solving just for v. We'll be using this equation since these are our givens. How much time is the question mark? 500 meters is going to be our x, and your velocity is 20 meters per second. So if we ever have to solve for v or t, you're going to have to rearrange this equation. So some people like to plug in numbers then rearrange. I usually rearrange first and then plug in numbers. So how would you rearrange this? We're solving for time. Time happens to be in the denominator, and something weird happens when anything is in the denominator. We cannot just get rid of x, because if we get rid of x, we're going to be left with 1/t. What we actually have to do, if it's in the denominator at the bottom of this equation, is we have to actually start by multiplying both sides by t. When we multiply both sides by t, we now get this equation, x equals vt. And I'm going to write this over here because this is important. If you're ever solving for x, I'm just going to rewrite it in a different, this is the same thing. If you're ever solving for x, the equation for x is equal to v times t. So that's how you'd solve for x. But I'm going to keep on going. I'll erase this for now. We go from there. Our x equals tv, and we now need to get rid of v. So to get rid of v, we're going to divide both sides by v. When we divide both sides by v, now we have t in the numerator, and if there's nothing on the bottom, that just means it's t over 1. So t is in the numerator, and that's equal to x over v. And we plug in our numbers, 500 for x, we plug in our 20 for our v, 20 meters per second, and what was the derived unit? Once again, if you just think time and you remember your units, when you get to the end, if you used SI units or MKS units like meters and meters per second you're going to get SI units out. So I know that I'm solving for time. My unit's going to be seconds because I use seconds going in. So 25 seconds, once again, circular answer, so I can see it easily in your work. So do the practice problems and then check your work with my work. Also, I have these on the StickMan Physics site. So some of them are in the quiz, where if you take the quiz, you'll be able to check your answers at the very end, and it'll give you feedback on what you did. I'm just going to work through these for now to help you out. But you want to make sure you do these once again on your own first. You don't want to just copy what I'm doing. So during lunch break, on his lunch break, Thomas took 30 minutes to go to the library and then the cafe. So what distance did Thomas travel during the lunch? I don't really need the 30 minutes right now. We're just going to go ahead and take a look. He went to the library and then the cafe. The distance you just add up, so it's going to be 145. Be careful here. He went all the way to the library, which is 145 feet. So this is just a placeholder for start to the cafe, but he goes an additional 45 meters to the library. But then he goes back 45 meters. And since he goes back 45 meters, it's a distance, so direction doesn't matter. We're just going to add those numbers together. And 145 times 45 is 190. And so we have 190, but we have to, once again, this is a magnitude, includes the unit, so it's 190 meters. His displacement for doing this would be 145 meters, but this one's going to be a positive 145 meters because direction matters, and so to the right it's going to be my positive sign. And I'm going to subtract the 45 because he goes left 45 meters from the original. And displacement's like saying, where is he at the end versus the original? And you can see off this graph, you can tell it's already 100. But this is just a way, if there was a lot of different directions if he was going back and forth, and we're trying to find the total displacement, it's going to be useful to always include the signs until you get to the end. In this case, it ends up being plus 100 when you add those two together. And the plus 100, the plus became, we could say right. If you say east, that's fine, but for all I know it's going to be right, or maybe forward from where he started. Okay, so we took 30 minutes to do this, and I did the conversion for you just to save you some time. It's 1800 seconds. To determine the speed, I'm going to go ahead and take the distance x of, and his whole trip was 190 meters. We have a time of 1,800 seconds, and we're asked for the speed, which we're using the distance for, so v equals x over t. V equals x, which is 190, divided by t, which is 1800. And when we type those numbers in, we get 190 divided by 1800. We get an answer of 0.105 meters per second. What was the velocity of Thomas during the 30 minutes? Well, now we're going to go ahead and we're going to pull the 100 meters right as our x. And we're going to have a t of 1800 meters. And we're going to have a v of, 1800 seconds. And then we're going to have a velocity that we're trying to solve for. And now we're going to go ahead and do v equals x over t. And x equals and often instead of, I'm just going to write these numbers to the right of this. X is 100. And the time is 1800. And so when we answer this question, 100 divided by 1800 equals 0.055 repeating. So we'll just go ahead and go with a 6 right here. I'm kind of disregarding scientific notation on this, or sig figs, but 0.0556, but it's going to be important to have meters per second because that would have been meters, that would have been seconds. And also this would be to the right because this is really going to be to the right. The direction on the x on the top would have been to the right because it's a vector for displacement. What's the direction in 15 meters north? So at this point in time, you'll be doing the quiz at the bottom. This is where you're going to be able to check your work here. And of course, you're watching this video, so you can check your work by looking at what I'm doing. What's the direction of 15 meters north? It's going to be north. What's the unit of 15 meters north? That's going to be meters. What's the magnitude of 15 meters north? That's going to be 15 meters. That's going to include, the magnitude is going to be the number and the unit. What's your displacement after going 10 meters east followed by 20 meters west in 10 seconds? Well, displacement, I'm not worried about the seconds. I'm going to go, it's going to be a vector, so I need to know direction. So plus 10. And then I'm going to add the negative 20 to that because you go west 20. And so I'm going to get an answer of negative 10. And I turn that back into direction. It's going to be 10. And I was in meters. And I called east positive, and I called west negative. Since the answer is negative, it's going to be west. What's the average velocity after going 10 meters east followed by 20 meters west in 10 seconds? So we're going to take our displacement, x equals 10 meters west, and we're going to go ahead and it takes 10 seconds to do this, and we're solving for v, and we get v equals x over t. V equals x, which is 10 over 10, so we're going to get 1 meters per second. It is a velocity, so we have to include our direction. West is a vector. What's your average speed after going 10 meters east followed? Okay, so the difference here, now to solve for our x, we're just adding, because it's speed, it's a scalar. So remember that 10 plus 20, So we go 30 meters, and we do that in a time of 10 seconds. And so when we're solving for velocity, v equals x over t, it's going to be v equals x, which is 30 meters, over time, which is 10 seconds. So we get 3 meters per second, no direction included. Okay, so 15 meters per second is meters per second is going to be, it's missing north, so it's missing any sort of direction. So you're going to have a magnitude. So it's going to be a magnitude. And since it's going to be speed or velocity, but in this case it's going to be speed, and speed is a scalar. So speed is meters per second, and it has no direction, so it's a scalar. 15 meters east, well, 15 meters is going to be either distance or displacement, but since it has east, it's going to be displacement. So it's going to be a vector. Vectors have vector displacement. There's your answer right there. What's your displacement after going 10 meters east followed by 3 meters west? Well, there's going to be your plus 10 for east, 10 meters east, followed by -3, and we're going to get a positive 7 or 7 meters east because the positive stood for east. What's your distance after going 10 meters east followed by 13 meters west? We just add the numbers together because distance is a scalar, 13 meters, and that's it. Ignore any sort of direction. And I think this is the last one. Sam takes 500 seconds to travel 300 meters from home to work. During his trip, he stops at a red light and his speedometer reads 0 meters per second. What is Sam's instantaneous velocity at the red light? Well, at the red light, he stopped. So his instantaneous velocity is 0 meters per second. And have a good one. Thank you. Hopefully you enjoyed this lesson.